Hi, I'm Dominique DeLima, and this video project is on intermediate value theorem. The definition of intermediate value theorem states, suppose that f is continuous on the closed interval ab, and let n be any number between f of a and f of b, where f of a does not equal f of b. Then there exists a number c in the open interval ab such that f of c equals n. But what does this definition actually mean? Well, it can be understood a lot better by looking at a graph. On this one, we already have a and b, and f of a and f of b, where f of a does not equal f of b. Then the function has to be continuous, so we can draw in some continuous function here. We also know that there is a number n between f of a and f of b, and then, according to IVT, there is some number c that is between a and b. A common application of IVT is finding roots. If you take a look at this graph, we can first draw a continuous function from a to b. Since we know that f of a is above the x-axis and f of b is below the x-axis, we can determine that there is a root between a and b. Using the definition of IVT, we would set 0 equal to n, and the root would be the value of c. It's important to note that IVT does not work for discontinuous functions. This is true because if you have a graph like this, the value of the whole could be at n and c. But IVT would not hold true since this is not a value of the function. A common mistake made is not stating the continuity of a function when using IVT, so make sure to do that. So let's take a look at an example IVT question. In this one, you are given a function and then asked to prove that it has a root between 0 and 1. The first step is to state continuity. You know that this function is continuous on the interval because it is a polynomial, so it is continuous from negative infinity to infinity. The next step is to plug in the values a and b. In this case, they are 1 and 0, since the interval given is 1 to 0. By plugging it into the function, you get f of 1 equals 1 and f of 0 equals negative 5. The final step is to state your conclusion. So we found that f of 0 is less than 0, which is less than f of 1, because f of 0 is negative 5, which is less than 0, and f of 1 is 1, which is greater than 0. So there is a root on the interval 0 to 1. And we can take this question even further by using IVT to estimate roots. Now instead of plugging in 0, we can use 0.2, and instead of 1, we can use 0.8. When we plug these in, we get negative 4.696 for f of 0.2, and we get negative 1.864 for f of 0.8. However, since 0.8 gives us a negative number, we can determine that the root lies between f of 0.8 and f of 1, because 0 lies between negative 1.864 and 1. Now we just continue this process to narrow down the root even more. Knowing it is between 0.8 and 1, we now plug in 0.9 and 1, and for 0.9 we get negative 0.608, and for 1 we get 1. Eventually, you should get that the root is between f of 0.94 and f of 0.95. Okay, so now let's look at a different kind of example. The question asks, knowing f is continuous from 0 to 3, and that f of 0 equals 1, and f of 3 equals 2, what is guaranteed by IVT? Well, IVT states that plugging in c will get you a number n that is between f of a and f of b. Therefore, g of c has to be in between negative 1 and 2. The answer also has to be between a and b, which in this case is 0 and 3. So therefore the answer is C, because 1 is between negative 1 and 2, and it's on the interval between 0 and 3. Here's another example problem. You're given a chart of values for x and f of x. It's given that f is continuous in this interval. The question asks, what interval must contain the solution of f of x equals 4? Well, this question actually has multiple answers, but we'll focus on the narrowest interval we can find. Now, according to IVT, we are given the value f of x equals 4, which is n in IVT. We are trying to find the value of a and b, which is the interval. Since the chart shows that f of 1 is 2 and f of 2 is 6, you know that 4 must fall somewhere in this range. Since you know from IVT that f of a and f of b are 2 and 6, you know that a and b are 1 and 2. So that must be the interval that f of x equals 4 is on. However, between 0 and 2 would also be a correct answer, but just not the most narrow answer. So let's summarize what we've learned about IVT. There's some prerequisites for using the theorem, and these often result in common mistakes. The first is continuity. IVT states that f of x must be continuous on the closed interval a to b. The second is that f of a cannot equal f of b. Additionally, it is important to know that IVT can be used to find or estimate the roots of a function. Thanks for watching. I hope you found this video helpful.